Welcome to the Day 4 video, which covers Section 8, Quadratic Inequalities. As you can guess, today we're going to graph quadratic inequalities. You will not need a calculator. This is very similar to Section 1, graphing in standard form. So you're going to be given a quadratic that looks like it's in standard form, but instead of an equation, it's going to be an inequality, which means we're going to introduce shading. So looking at the first example, we have y is greater than x squared plus 2x plus 1. You're asked to find the vertex, the axis of symmetry, and the y-intercept. Now remember from before with standard form that our vertex is negative b over 2a. A is what's in front of the x squared, b is in front of the x, and c is the constant. It doesn't have an x. So in this case, this is negative 2 over 2 multiplied by 1, which is negative 1. So our vertex is negative 1 comma some other number. Now to figure out what the y value is, we're going to have to substitute negative 1 in. So I have negative 1 squared plus 2 times negative 1 plus 1. So this is 1, add negative 2, add 1, which is 0. So our vertex is 1, 0. Now remember that the axis of symmetry goes along with the vertex. It's just the x-coordinate of the vertex. So your axis of symmetry is x equals negative 1. It needs to be written as x equals negative 1. If you write negative 1, that's wrong. That's not specific enough. Writing x equals negative 1 reminds us that this is going to be a vertical line. Now for your y-intercept, remember that your y-intercept is 0, comma y. In order to figure out that y value, we have to substitute in 0. So we get 0 squared plus 2 times 0 plus 1, which is just 1. So also remember we've talked about before how your y-intercept is actually just the c value. So this should all be review. Graphing is going to be really similar. So put your axis of symmetry at negative 1. And then our vertex is negative 1, 0. And now we're going to need to fill out our table. Vertex goes in the middle. Sorry, negative 1, 0. We're going to go down 2 values and up 2 values. Now I already substituted in 0. That's the y-intercept. I know that's 0, 1. So I have 3 more to substitute in. Negative 3, negative 2, and 1. If I substitute in 1, I get 1 squared plus 2 times 1 plus 1. So this is 1 plus 2 plus 1, which is 4. If I substitute in negative 2, I get negative 2 squared plus 2 times negative 2 plus 1. So this is 4 plus negative 4 plus 1, which is 1. And then if I substitute in negative 3, I get negative 3 squared plus 2 times negative 3 plus 1. So this is 9, add negative 6, add 1. 9 add negative 6 is 3. 3 add 1 is 4. Now remember, because of the symmetry of a parabola, these values are always going to match. So really, all I needed to do was substitute these 2 values in, and then I would know that my other 2 points were negative 3, 4, and negative 2, 1. I'm going to substitute all the points in just so that I can check my answer. Now we're going to plot the 5 points in our table. So I have 0, 1, 1, 4, negative 2, 1, and negative 3, 4. Okay, so all of this should be review from what we did before. Here's what changes now. Because we have y is greater than in our equation, this is going to be a dotted parabola. It's not solid because we don't have the equal. So remember from before, if I have greater than or less than, it's going to be a dotted or a dashed line. Greater than or equal to or less than or equal to is going to be a solid line. And then remember, with an inequality, you have to determine where to shade. So before, in order to determine the shading, we've always looked at a test point. So we need to pick an obvious test point that's not on the parabola. Normally, we choose the point 0, 0. So I'm going to choose 0, 0. I get 0 is greater than 0 squared plus 2 times 0 plus 1. So I get 0 is greater than 1. This is not true. We do not want to shade where 0, 0 is. 0, 0 is outside of the parabola. We don't want to shade where 0, 0 is, so we're going to shade inside. So that was example number 1. Again, really all that's different is the dotted or the solid line and the shading. Everything else should be the same as from section 1 when we graphed in standard form. Let's do one more together, and then you all can do one on your own. Okay, so here's our next one. Before we start the problem, I'm going to ask you to change it a little bit. Take away that 2, so we have negative x squared, and then change that 3 to a 4. So we're going to graph y is less than or equal to negative x squared plus 4x plus 5. Starting with your vertex, our vertex is going to be negative b over 2a, which is negative 4 over 2 times negative 2, which is just 2. So our vertex is 2 comma some number. Now to find the y value, we have to substitute that 2 back in. So I get negative 2 squared plus 4 times 2, add 5. So this is negative 4, add 8, add 5. Negative 4 add 8 is 4. 4 add 5 is 9. So our vertex is 2 comma 9. Our axis of symmetry goes along with the vertex, so it's x equals 2. And then our y-intercept happens when we substitute 0 for x. When I substitute 0 for x, I should get 5 for y, because remember it's just the c value. Now, starting my table, I'm going to put my vertex in the middle, 2, 9, go down 2 values, 1, 0, and go up 3, 4. I know the point 0, 5 already. Okay, at this point, I know that these are going to be symmetric, so I know it's going to be 4, 5. And I know that 1 and 3 are going to be the same value. I'm going to substitute both 1 and 3 in just to check my answer, just to make sure that I get the same value. When I substitute 1 in, I get negative 1 squared plus 4 times 1 plus 5. This is negative 1 plus 4 plus 5, which is 8. I should get the same thing when I substitute 3 in. This becomes negative 9, add 12, add 5, which is 3, add 5, which is 8. Now I'm ready to graph. I'm going to start by putting in my axis of symmetry at x equals 2. My vertex is 2, 9, and then I have 1, 8, and I have 3, 8. I have 0, 5, and then 4, 5. Okay, this time we have less than or equal to, so this is going to be solid instead of dashed. Okay, so first thing, why is my parabola opening down? Does that make sense? Well, remember that we have a negative x squared. Negative x squared is what makes the parabola open down. It's always good just to do that mental check to make sure we didn't make a mistake. Now, we are not finished yet. We still have to figure out the shading. So remember to pick a test point. I'm going to pick the origin again, so I'm going to pick 0, 0. I get 0 is less than or equal to negative 0 squared plus 4 times 0 plus 5. So 0 is less than or equal to 5. That is true, so I want to shade where 0, 0 is. 0, 0 is inside the parabola, so we're going to shade inside our parabola. Okay, so again, all that's new is the solid or dashed and figuring out the shading. Flip the page to look at a few more examples. Okay, this next example is one that you're going to do on your own. So I would like you to pause the video and try this third example on your own, please. Okay, let's see how we did. You should have done x equals negative b over 2a to find the vertex, which is negative 2 over 2 times 1. So your vertex should be negative 1 comma some y. To figure out the y, you substitute in negative 1. This is 1 minus 2 minus 8, which should have been negative 9. So that goes in the middle of your table. Your axis of symmetry then is x equals -1. And your y-intercept should have been 0, -8. Because when you substitute in 0, you get -8. It's the c value. Now to finish out our table, you should go down 2 values, so -2 and -3, and up to 0, 1. We already know 0, -8. That tells us by the symmetry that -2, -8 is a point. And then you should have substituted -3 or 1 in to find the y value, because remember they're going to be the same by symmetry. Substituting in 1, this gives me 1 squared plus 2 times 1 minus 8. So this is 1 add 2 minus 8. So 3 minus 8 is going to be -5. Okay, so our axis of symmetry is at -1, which is here. My vertex is at -1, -9. I have 0, -8, and -2, -8. And then I have 1, -5, and -3, -5. This is not equal to, so you should have a dashed parabola. Now to figure out the shading, you should substitute a value in again. I probably would have substituted in the origin, but you don't have to choose that one. You can choose any point that is not on the parabola. So if you substitute in the origin, you get 0 squared plus 2 times 0 minus 8 is greater than 0. -8 is greater than 0. That is not true. So I want to shade away from 0, 0. 0, 0 is in the middle of the parabola, so I want to shade outside of the parabola. So that's what you should have gotten. Before we look at that last example, quick piece of trivia. Who was the first American-born President of the United States? Do you know this one? First American-born President of the United States is Martin Van Buren. So he was the 8th president. The other 7 presidents were of English or Irish descent. So he was the first American citizen after the United States won its independence. Okay, we have one more example to do. Now this example looks very similar to how I had us change the other example, so we're going to change this one also. You're going to be graphing y is greater than or equal to -x squared. Add 8x minus 10. So, right now, pause the video and try this one on your own, please. Come back when you are finished. Good luck. Okay, let's see how we did. Now, I'm not going to show you any of the work. You should have gotten your vertex to be 4, 6, your axis of symmetry to be x equals 4, and your y-intercept to be 0, -10. Remember that your axis of symmetry needs to be an equation, x equals 4. It's a vertical line. Now, in our table then, we're going to have 4, 6. You should have gone down 2 and up 2. Now, you'll notice the y-intercept is not in the table. So you had to substitute at least 2 points in. You know that 3 and 5 are the same, and 2 and 6 are the same. So you should have substituted in 2 or 6, and 3 or 5. If you substitute in 2, you get 2. That means 6, 2 is our other point. If you substitute in 3, you get 5. So 5, 5 is our other point. Now, graphing this. Here's your axis of symmetry. You should have gotten 4, 6, 5, 5, and 3, 5, and then 2, 2, and 6, 2. It also would not have been a bad idea to substitute in that y-intercept or to plot that y-intercept. Now this should have been a solid line because we have greater than or equal to. Now, to figure out the shading, you should have substituted in 0, 0. When you do that, your shading is everything outside. Now, if you made any mistakes, you need to go back and find those mistakes. Come to class tomorrow with any questions that you may have. We will be checking all of your notes and to see that you have the work for this last problem. Again, if you have any questions, please bring them to class. See you tomorrow.